Hello, my name is Chinedum Osuji. I'm a professor in the Department of Chemical and Biomolecular Engineering in the School of Engineering and Applied Science at the University of Pennsylvania. It's my pleasure to introduce to you our new National Science Foundation Research Traineeship Program on interdisciplinary training in data-driven soft materials research and science policy. My co-PIs are Professor Russ Composto in the Department of Material Science and Engineering, Professor Zara Fakrai, Associate Professor of Chemistry, Dr. Kristen Field from the School of Engineering and Applied Science, who is our Program Coordinator and Director of Education, Professor Andrea Liu, Professor of Physics and Astronomy, and Professor Paris Perdikaris, who's an Assistant Professor in Mechanical Engineering and Applied Mechanics, and Applied Mathematics and Computer Science. The vision of this NERT is to create an integrated program that equips trainees, as it's written here, to advance soft materials research, groundbreaking soft materials research using autonomous experimentation, and a program that positions them to make impactful contributions beyond the lab by leveraging science policy. This NRT will train 50 PhD students, 20 of whom are directly funded by the NRT, in what we consider to be a new paradigm for tackling high complexity problems in soft materials research. At the heart of this NRT is a fusion of computer science, a term that I use here to collectively refer to machine learning and data science, with the traditional interdisciplinary approaches used in materials research, i.e. physics, chemistry, biology, and engineering. The idea is to make it possible to advance the rate at which we develop new materials in the soft materials area by leveraging autonomous experimentation. That's what's shown or depicted schematically in the bottom left here. This is a diagram showing a workflow associated with autonomous experimentation based on scattering, X-ray scattering data. And on the right is a physical platform associated with the execution of a computer-driven set of experiments. Autonomous experimentation is a new and rapidly growing field that is harnessing the power of computers, not just for the execution, the physical execution of experiments through computer control of instruments and apparatus, but for computerized decision-making about what experiment to perform next. So autonomous experimentation is not blind, high-throughput sampling of a high-dimensional parameter space, but it's computer-driven analysis of experimental data that's used to make decisions about what experiment to perform next, such that the knowledge regarding the connection between the parameters in that space and the properties of interest can be generated most rapidly or most efficiently. The major research elements of the NRT include autonomous experimentation itself in the development of platforms for AE, as well as exploration of the limits of machine learning in looking at very, very complex high-dimensional parameter spaces. Colloidal and macromolecular materials, so we are looking at soft materials research, particularly for sustainability. And the third and final major research area is in soft living materials, where specifically we are looking at microbial ecology and fluid dynamics. There are several programmatic elements to the NRT, some of which are described here. One of them is immersive experiences, or IEs. Each NRT trainee will engage in an immersive experience during which they spend time focused on science policy or research, for example, at a partner institution. For example, they may spend several weeks on a science policy-based internship in Washington, DC, or they may visit Brookhaven National Lab, where our collaborator, Dr. Kevin Yeager from the Center for Functional Nanomaterials is a group leader in the Electronic Nanomaterials Group. Dr. Kevin Yeager is an expert in autonomous experimentation, and this NRT, in fact, is a collaboration that also involves Brookhaven National Lab through Dr. Kevin Yeager. There is also a Grand Societal Challenges Workshop, which in fact is the fifth or one of 5 core courses within the NRT. There is a network building seminar series that is built on the 3 pillars, the 3 intellectual pillars of the NRT, meaning soft materials research, data science, and science policy. And overall, there's an individualized integration of activities. There's a long list of program elements, which include things like writing workshops, for example, and individual development plans. Trainees in the NRT will have an individualized integration of activities that are tailored to suit their professional development or career goals. The impact of the NRT is felt in several ways. One of the ways that we hope it will be felt is through the dissemination of designs and methodology associated with autonomous experimentation for soft materials. The NRT has developed an institutional network for diversity. This, at present, is a nascent group of 4 minority-serving institutions that have partnered with the NRT with a goal of increasing the dissemination of the intellectual products of the NRT, and also of improving the recruitment and retention of a diverse set of trainees. So this institutional network involves engagement, personnel exchanges between Penn and members of this network. It involves also coding boot camps. And the goal of the NRT is to grow this institutional network by 1 to 2 members per year, such that the total number is around 10 at the end of the 5-year funding period. The NRT also entails a certificate program. So students at Penn who go through the 5 core courses involved in the NRT will receive a certificate based on their successful completion of those courses. And those courses, of course, and the curriculum that they will go through are all focused on autonomous experimentation and science policy. Thank you for your attention.